So today I'm going to touch on a few topics, kind of following on from the previous talk, where he kind of mentioned sort of the increased sort of visibility of compliance and the increased visibility of automation coming sort of as a result of changes in the infrastructure world and the development world through DevOps. So we're going to be looking at a particular project that I've been using and is being increasingly widely used called OPA Policy Agent. So a bit about me, John McCabe. I'm a software engineer at Proofpoint. I started off back when you would go and physically mount a rack and wire stuff up yourself before VMs, before containers, before anything like that. And you'd waste a huge amount of time, and then we got VMs, and suddenly things were more sort of controlled and you could sort of do things more efficiently, more quickly. And then containers came along, and you got increased sort of agility there as well. And I've worked in automation at Puppet and on the Apache Brooklyn project, specifically focused on this idea of automating and removing friction and sort of removing the human part from process where we're not great at following. So, Proofpoint, just got to do the obligatory thing. We're hiring, so we've a booth out in the stall if you want to kind of drop by and have a chat. We're recruiting for quite a few roles here in Belfast. So we'll start off by just asking the simple question, what is compliance? It's not hard. It's following rules and meeting standards. And as time goes on, organizations are facing increasing sort of numbers of regulations and requirements, whether it's statutory or contractual or legal, that they need to follow. And that can impact infrastructure. It can impact software. It touches all parts of the organizations now. So compliance with what? So you're compliant with a policy. It's not hard. A policy is just a rule. So your organization has a set of security policies, perhaps, that identify the rules and processes and procedures that everybody in the organization is expected to follow, that if you run a service in production, you need to have X, Y, Z sort of completed so that we know that we're sort of compliant with whatever sort of policies that are contingent on us. It's usually a good sort of model of an organization's culture. You can kind of see from the policies how an organization has evolved over time. And quite often, the approach is very manual. It's very human. There's like a sort of an oral tradition to policy, and it's all sort of very sort of person to person. Is this okay? We have policies. We have compliance. Is this actually okay? I would contend it's not. That's kind of the crux of the talk I'm going to have here. I don't think it's actually working particularly well, sort of across most organizations. The problem invariably comes down to you're seeing a disjoint in the rate of evolution between the sort of the gatekeepers of security and compliance in an organization and the technologies that are increasingly sort of resulting in sort of speed and iteration, and things are increasingly ephemeral. It's very hard to keep track. And security policy specifically in organizations, quite often it's Jira tickets, it's spreadsheets, it's Word documents, wiki pages. These aren't great things. You're describing sort of very important policies and requirements human to human, and that's very difficult because you can have misunderstanding. You can have the bandwidth as you increase the number of policies, it breaks down. You can only remember so many things. So what you'll find is new policies come out. There's a flurry of activity. Everybody's very busy. Everything gets dropped. Okay, you're compliant. And then over time, are you still compliant? Are there services that are sort of haven't been touched for a while because the project hasn't had people working on it? Are they now non-compliant? There's a lot of gaps where things fall through, and it's predominantly down to us having what's effectively a process-driven approach to policy and compliance. So process is squishy. Process is human to human. It's writing down instructions for other humans to follow in human languages. It's not reliable. We're all human. Humans make mistakes. The best engineers in the world make mistakes. And they tend to be the worst ones because they tend to be the ones that you don't think you could have ever made, like a slip. It doesn't register. So process-driven approach to sort of compliance and policy is not great. So how could we fix it? What can we do here? Could we write more spreadsheets? Fix the wiki pages? I think we need to look outside of kind of what we've been doing, to this point, and look at sort of advances elsewhere, sort of in the ecosystem. And specifically, we're talking about policy as code here, where we want to sort of take what we had described in our spreadsheets, described in our wikis and our Jira tickets, and actually turn that into code, turn that into something that is objectively true, and it's testable, and it's something that you can't have ambiguity around. So we should learn from DevOps. So we've all seen sort of what's happened with sort of ops and infrastructure and dev and so on, where they've kind of had this realization that their processes weren't good enough, that they had a lot of manual processes that were prone to mistakes and just didn't scale, especially with the evolution with the emergence of cloud and sort of Kubernetes and so on. It just does not scale. So, what did they do? They doubled down on what they know best, software development lifecycle. So you write code, you don't write process. You leverage version control. You take advantage of that. Branching, peer reviews, sort of all these sorts of things, change review flows. A big part of like implementing a policy is that you need to be clear that everybody understands it. It needs to have been sort of given a blessing by the InfoSec team, the GIS team, whoever is the ultimate authority for codifying the sort of the policy that you want to enforce. So it gives them an opportunity to act as a blocking reviewer. So you can't actually have a policy pushed out and enforced unless it's been approved by GIS. It gives them control, keeps the control there. You also get sort of improved auditing and forensics. Things are now logged. Things are now timestamped. You can see who's changed something, where they've changed it, when they've changed it. And if you build systems around this rather than building process, you can retrospectively go back and look at logs and look at where things happened. It gives you a sort of foothold to improve how you implement policy across an organization. And then, of course, automated testing, automated deployment. And automation is a key part of this. Automation is just getting the human parts out of the process. We still need to figure out what policy means, what being compliant means, but we shouldn't have to be the ones that do it because we're not very good at it. So one project that sort of can help us here is the Open Policy Agent. So Open Policy Agent has been around, I think, since 2016. It is fully open source. As of April this year, it was adopted into the CNCF incubator. It's sort of sponsored and supported by Styra, sort of the company that the founders sort of created around it. And this is an important part. It's a general purpose policy engine. Okay, I know I kind of mentioned Kubernetes in the description of the talk. It's a general purpose engine, and we'll see how important that is. The language, the declarative language, it's Rego, which is based on data log. It's not a general purpose language. It's designed for writing rules, and rules are policies. Okay, and it lets us do things sort of more straightforwardly that we could do in a kind of another language. And it's available either as a daemon or CLI, sort of all implemented in Go, or a library which is increasingly becoming quite interesting in that you don't have to just download the service or to run it from the project. You can pull in the library, bake it into whatever you want, bake it into a command line tool, bake it into some other custom service that you've written. You can pull the core logic, the parser and the evaluator and the interpreter, pull it into whatever you need that fits best for your organization, and you're leveraging the same sort of policy engine that everybody else has, regardless of how they're interacting with it. So there's a couple of projects, I think we touch on one of them later, where we've seen people do that in the community. So it has a pretty sort of simple aim. Its aim is to unify policy enforcement across the stack. We've silos everywhere. Everybody does things differently. That makes the job of security engineers extremely difficult because suddenly they need to know everything. The reason why cloud took off is because previously engineers deploying systems into production, they needed to know everything. They needed to know networking and physically racking things and all the different servers and the nuances of the operating systems. When AWS came along and they started taking like a contract-driven approach to this, and you suddenly remove the need to know how the sausage is being made behind the scenes. You just take the contract and you use the contract, and it's not your responsibility how it happens, and it suddenly decouples you and frees you up to, so you kind of have the same idea with sort of having sort of a unified policy across the stack. Suddenly, if you're using Terraform, if you're using Chef or Puppet or AWS or Google, suddenly the way in which you implement your policies is just one implementation. The data structures might change, but it's one set of tooling, it's one set of processes. You've only one thing to learn, which is very attractive. So, yeah, very simple at its core. So this is OPA. So say you have a service that wants to use OPA to sort of, make a decision about whether it's allowed to do something. So it sends a query, and the query just takes the body. OPA works on JSON objects. So it takes a JSON object, it applies its rules to that object, and it returns a JSON object that represents whatever an allow or deny makes sense in your particular context. You can configure what the response looks like for the allow case and the deny case. So you would get in a query, JSON object, maybe it's a path, a username, and so on. It goes to OPA. OPA has policy, so individual sort of policies are sort of stored in memory in OPA. And it also has the ability to store additional data. So what you can end up doing with the policies can effectively be parameterized and data driven. So you could see a situation where you have one team perhaps is responsible for writing policy, and then another team decides how they ratchet it up or ratchet it down, who it gets applied to, and so on. So your query comes in, the OPA engine checks all policies against it to see if anybody denies it. So it just ands all the rules together. So if anything says no, then you get a response back to the service saying, no, you're not allowed. And that can include contextual information. So, no, you're not allowed because of X. And because it evaluates all policies at the same time, you're not playing whack-a-mole. You immediately get back, you're violating because of X, Y, Z, A, B, C. You just get it all. So it's quite a nice experience for the consumer and your end user. So the community at the minute, there's quite a lot of significant companies already using this in production. So Netflix are using it for access control to their microservices. Chef use it to deliver IAM capabilities in some of their products, I believe. And you've dozens of others using it to enforce sort of policy in Kubernetes or what have you. Some of the most common use cases that you've seen are admission control, which is what we're going to talk at in the context of Kubernetes. Authorization, so people are using it in Kafka, in microservices, things like that. You can hook it into PAM and use it to sort of authorize who can and can't log into a box or who can and can't get pseudo access. Risk management, you want to make sure that, for example, Terraform, there's an example we'll look at later where Terraform's notorious where it's easy to accidentally make a small change that results in loads of things getting changed. You can sort of manage that risk by having a policy that says, I'm going to wait all the possible changes you can make. And if you exceed a certain value, then it's no, you're not allowed to do that. We need to flag it up, figure out what's going on so you don't accidentally do more than you think you're going to do. Data protection, so filtering, for example, in Kafka, you can kind of restrict who can see what. And data filtering is just the same thing again. So an example input. So this would perhaps be an example input from a microservice where you have an authenticated user, Bob, and they're interacting. They've sort of talking to the microservice at the finance salary / Alice path. So that's their context there, and they've made a get. And we want to know if user Bob can see Alice's salary. So previously, the developer would have to codify that and put it into their service. So if you suddenly decide we need to change the policy, I need to get Jira tickets raised and an epic created. I need to talk to the product manager. It could take weeks. It could take months to get things done potentially. So by decoupling the policy from that, suddenly you're able to tweak the policy without having to go back and rewrite the services. So a policy for that, for example, would be, you're inputting the input. So the object that comes in is always referenced as the input. You set the default, so the rule is the allow. So the default response for a rule in this case is false. So it's like, by default, you're not getting access. And then we've one instance of a rule, an allow rule, where we're just some username, we're just setting up the variable, and we're making sure that the input method has to be get. We only allow gets. And the input path has to be finance, salary, and username. And what it's going to do here is this is going to then sort of initialize username with the value that you've just passed in. And then it's going to check to see if your user is the same as the username in the path. So this lets you basically prevent you from looking at somebody else's salary. And the thing with this is testable. You can suddenly write unit tests for this that you can automate and you can run, and you build up your matrix of all possible combinations of things that can change, and you can get like a pretty good level of trust that a policy will do what you want it to do. So say, for example, you wanted to, okay, now the manager wants to see a user salary. Okay, well, we need to provide some additional data. So this is where this data object at the top. So we're saying Alice doesn't have any subordinates. Bob, Alice works for Bob. Betty, John works for Betty, and John doesn't have anybody working for them. It's just another allow rule. So it's the same rule. So both rules are now going to get evaluated. Setting up the username that it's a get, it's pulling out the username, but now it's checking to see if the input user exists as a subordinate to the requesting user. So suddenly you've got the ability, and if you were to, that's quite a significant change in your policy enforcement, but you've been able to do it with one or two lines of code in your policy engine, because and it becomes very, very powerful. And that's just a sort of a basic example. So using OPA, you have a couple of options. You've got a service, you can just run a daemon. You have a CLI, so you can just take some JSON objects on disk and just pipe them together, on the command line or in a pipeline, and just use the command line. There's a full REPL when you're first starting to get used to it. You can just OPA run and go in and experiment and play with things and so on. As I mentioned, the library, and you can compose it into other things. So one thing that sort of was recently, there's a project called Contest, the guy Gareth Rushgrove, where he's basically pulled the whole OPA policy part into a tool for specifically focused on testing in pipelines. Somebody has written a Helm plugin, so you can just do Helm OPA, and you can do policy validation on your Helm chart. Like, for example, it could be you must have certain labels, you must not run as root, and it's just Helm OPA. So you suddenly, by making it available like that, you've not given somebody another process to interact with. You've been able to take the key part of it that you want and just push it into people's existing workflows transparently, or as transparently as possible, which is very important. So, okay, we've got a way of codifying policy, so that we're a little bit better, but now we need to remember to do it. We shouldn't. We need to automate doing that. It needs to be just something that happens for free every time, all the time. So you have various levels of maturity in terms of how people do this in organizations. Most people are using pipelines. Some organizations are starting to move towards GitOps. People are using like Argo and things like that in Kubernetes. There's different levels of sort of sophistication, but they're ultimately doing the same thing. They're just automating what was previously a manual process. So for example, here, this could be an example of just a Jenkins pipeline where you check out your this is a Terraform chart or Terraform plan gets checked out. There's an initial step where it unit tests it. It applies the policy validation. So if you try and do something in your Helm chart or in your Terraform plan that is non-compliant with whatever your rules are, it'll just fail immediately. It'll give you back context. You failed because of this. You don't need to go and talk to somebody in a security team to figure out what's going on. It just tells you, do this, fix it. You'll be unblocked. And then in this case, it's passed, so it's gone ahead and it's applied itself to dev. You've manual gating promotions. So you can do all the things that you would still want to do. You still have control over what policies get enforced. You still have control over, manual control about gating to production. So it just gives you a lot of sort of power here. Then the policies itself. You want to unit test policies. So this is an example of a policy that's actually packaged up. So the policies are packaged up with OPA in a Helm chart. So anytime you change policy, everything gets pushed out. So you can see it's building all of the components. It's testing the policies. So there's a OPA test command, and it runs unit tests. And then it's testing, and the testing can include you deploy OPA, and then you run a series of actual integration tests where it's like, okay, I have a policy that I can't pull from Docker. It will try and spin up a pod or a deployment and pull from Docker, and they should be rejected. It'll try and spin something up from an internal cache. It should be allowed. So you get this ongoing sort of verification rather than trust occurring. And then for people using GitOps, so this is an example of just a small sort of application that was written to sort of run in GitHub, where you just attach the application to your organization. So this is really hacky. This is something I kind of just threw together. But like, you could see this being something that you just throw it across your organization. It's clever enough to know what type of project am I looking for. Am I looking at Terraform? Am I looking at Helm? Am I looking at something that might be using a secret in the wrong way? And you could end up just having like, one application that applies and does the right thing in the right context and just disappears into your workflow. And that workflow is a big part of it. You want to kind of disappear into the background for users. So it's never that simple. That's all very easy. Very easy for me to say that. It's binary. Sort of, you're allowed to do something, you're not allowed to do something. Reality is, we have non-compliance. So you have existing non-compliance is usually one of the big ones. You want to roll out a new policy. You either stop the world and break your system for users that are non-compliant at that point in time, or you have to pester and corral non-compliant services to get updated, which can be time-consuming. They may not even be resourced a particular instance. So you need some way of dealing with the reality that you're not just going to get instant compliance. So you want the ability to sort of have exceptions, have allowances. Maybe some service needs to be non-compliant for a very specific business reason. Again, that then goes through the normal processes of evaluation, but it gets codified as an exception in the policy. And when you do the exceptions, the allowances, you still do it using policy as code. Authority still remains with security. They still are the ones that get to decide what has an allowance, what doesn't have an allowance. You want visibility, you get better visibility of it. You can have it so that, first of all, the single source of truth there is the repository. The things that have an exception are in code in a repository, so you can see them. You can integrate sort of it into logging like Splunk, so you can have a dashboard that shows you attempts to violate a policy, where they're coming from, who's trying it, sort of the usage of services that have an exception and are violating. It's like they've said they were going to reduce and migrate across, but they're still running and still being used. So there's a lot of things you can get there that improve visibility and the ability to track how policies are being adhered to or not adhered to. So it's this idea of ratcheting. What you don't want to have happen is delay pushing out a policy because you need to wait for everybody to be ready. You just push it out, and everybody that's compliant can never go backwards. Anybody new must immediately be compliant, and you just turn the heat up on people who are currently compliant. But very important that just speeds getting policy out. So what does that look like in Kubernetes? So it's kind of cut off a little bit at the side. So Kubernetes has this concept of an admission controller. An admission controller is basically a gatekeeper that sits in front of the API server and says whether you're allowed to create a resource or not create a resource. So, if you're interacting with Kubernetes, either via CI/CD or the kube control command line, or you've got a controller running in Kubernetes, it talks to the API server. It goes through the authorization and authentication, your ORBAC piece, and then it hits the admission controller. So it hits mutating admission controllers, which are, say, for example, you always wanted to tag certain labels on every resource. You could implement that in a mutating policy that it just happens for you and you don't need to know about it. Say, for example, you don't want anybody using Docker, but you have a cache. It just automatically updates references to images and points them at the cache. You have a lot of flexibility to do things there. And then what we're talking about today is the validation. This is, do you adhere to policy? You're allowed or you're denied. And what this does is it looks at the requested object. So it looks at it's an admission review request, this object. And it checks it against the policies that you've defined in OPA, and either lets you through or doesn't let you through. And what's very nice about it is that if it does reject you, it passes back very, very actionable information. You can pass back all the detail of you're not allowed to do X because of Y. You should do this. So that reduces the friction. You don't want tickets coming out of these things. So the Gatekeeper implementation, because as I say, OPA is a general purpose. We need to, how do we get it working in Kubernetes? So it actually works in Kubernetes in conjunction with a sidecar called kube management. And kube management handles, it looks at configuration maps, which is just like blobs of YAML that you can sort of create in Kubernetes. It looks for the creation of those in specific namespaces with specific labels, and it pushes them in to OPA as policies, or it pushes them in as configuration data. So if you change a policy, you can just kube control apply a new config map. It'll get synchronized with OPA and pushed out. It also handles data replication. So say, for example, you get a request and you only know about, say, the service, but you want a rule that kind of needs to take into account ingress. So you need a different class of object. What kube management can do is handle replication of other resources in the cluster. So you can write policies that are able to reference information that's external to the request coming in. So you can do quite complicated policies with that. The point of contact with OPA and Kubernetes is this validating webhook configuration. All you're doing is saying if you get a request to create any resource that is picked up by, you have a selector there, so you don't just send it everything. You can select what are the types of resources that you want to get sent. If any of those come in, send them to this service, and you can use mutual TLS to kind of secure the communication between the API server and your OPA pods. So, similarly to what we saw before, a policy could be quite simple. So in this case, the logic is reversed in that we're not allowing, we're denying by default. So in this case, if any one of these rules, so like as I say, a rule, every line is a rule, if any one of those returned false, we'll actually treat that as an allow to go through. So in this case, what we're looking at is, we're looking to make sure that, okay, we're only looking at pods and deployments. If you're creating a cron job, we don't care. We're only looking at particular types of operations, updates and creates, perhaps. We don't care about patches for some reason. And then we have another rule that's being referenced here, image from valid registry. Now, this value at the end, that's a set that will get returned when that policy evaluates, which we're in turn returning to the deny. And what that is, that's the textual information as to why you've been denied. So you can make this data-driven, which opens up the ability to kind of separate. You could have policy in one repo and the data that drives policy in another. So here we're just saying, deployment and job, create an update, and you're only allowed pull from Docker. And then the allowed images, we're setting up the image variable. Container images is kind of one of the nice things that we have. So we're running this rule container images, and it's returning us a set of images. Okay, so if you can imagine that, we now have multiple images through that. We're making sure that it doesn't match any of the registries. So if for example, it doesn't match anything there, then we're using a non-allowed registry. So we go to the next line. So message is now defined. So we pass a message value up, which in turn passes up. So that's an occurrence of a deny. The container images. So pod security policies are a thing in Kubernetes. They can let you prevent a pod from doing a thing. And ultimately, that's kind of good enough, maybe, because ultimately a thing will create a pod. But the problem is, if I'm interacting and saying I want a deployment, and the deployment isn't a pod, but it contains a template for a pod, what would happen with a pod security policy is that I'll be allowed to create the deployment, but then it'll just sit there and I'll have to log it. I'll have to connect into kube control and have to check the state, and I'll say, oh, it's stuck in this container creating state because it's violating a pod security policy. Because we can kind of be more nuanced in OPA, I've got two rules, and they both get evaluated. One is looking at the object spec containers image, which is going to return all the images that you would see at the pod level. But the one below, you're getting it at the template level. So suddenly you have one rule that's giving you pods, deployments, Like we have examples that are like basically giving you images from every single thing that could possibly contain an image. Security contexts for, say, run as not root, sort of run as a specific user. You no longer have to define them on a per pod basis. You can have it so that they get rejected for every possible object immediately, which gives a very good end user experience. And then you try to deploy it. So I tried to sort of create a deployment with Docker. It's fine. It works as normal. But if I tried to use something from Google, it'll come back and say you're violating because you've tried to go to a non-supported registry. So it'll tell you what you've done wrong, and it can suggest how you fix it. So Kubernetes does provide some tools for security. It provides, like, there's a whole range of admission controllers for very specific purposes. So one that will ensure that you always pull images. It will never use an image that's already on a box. That can be useful, say, for example, where you're using images from sort of secured registries where some service that's allowed to pull an image pulls it, and another service that's scheduled on the same node can get the image, but it doesn't go through the authentication. So this kind of stops that whole, preventing you from execing like, privileged sort of execs or running as root. Image policies, there is a webhook that lets us restrict where you pull images from, but the problem is you're left with that situation. It only works on pods. So you could create a deployment and you're going to find hidden away sort of through kube control the actual failure. So it's not a very nice experience. And then we have pod security policies. Again, loads of security that you can apply, but at the pod level, using OPA lets you kind of pull it up a level so things fail as soon as we see them rather than sort of being hidden sort of behind the scenes. So OPA policies, again, it's configuration rather than code in this case. You're just defining the policy. You have full control over what that policy does. Like you saw in the first example, we went from locking down users to allowing managers to go in. You couldn't do that normally very easily without having to go through a dev cycle. We handle more than just pods. You get logging, auditing, alerting that you don't necessarily get in the others. You can write your policies in such a way, and there's extension points within OPA. Like there's this decision logger interface where you can have it hook in and maybe generate metrics so you can see what policies are violating, and you full metrics of that. You can generate like send events to Splunk every time a policy is violated. So you have a dashboard in Splunk and you can see who's actually not following the policy. And you come back to this thing of consistent tooling. You know, we want it to be more than just one tool. Gatekeeper 3, which is in beta, which we'll be getting quite soon, even comes out of the box with a standard library of Kubernetes policies. Because ultimately we'll all want to do the same thing. You know, there's a lot of sort of duplication in terms of sort of what policies you would want in Kubernetes. So Gatekeeper 3, it's going to give you all the same things. It's the same aim, but it's done in a Kubernetes way, Kubernetes native way. So instead of just a pod with a sidecar, it's nested CRDs. So a CRD in Kubernetes is, it gives Kubernetes full understanding of a particular data object as a native Kubernetes object. So it no longer is just a thing that's running on Kubernetes. It's now a thing that Kubernetes knows about. So you can go kube control, get constraints, get constraint templates, and it will give you those because it knows what those things are. So that's coming quite soon. There's a lot of active development. That mutation is going to be going into that. So you can the benefit of CRDs is because they're native, every tool that works with Kubernetes suddenly works now with your constraints. So if you have like a UI or if you have some other system that kind of knows how to work with object resources in Kubernetes, they just now work with this. So compliance in Terraform. So sure, most people are kind of aware of Terraform. It's a infrastructure as code sort of tool for automating deployments in the cloud and so on. And very widely used. And the key part for us is it can output JSON. So we've something that we can kind of apply policy to. So they have their own solution, HashiCorp Sentinel, kind of primarily focused on HashiCorp. I expect that'll change over time, but we can still use OPA with it. So the flow generally is a Terraform plan, convert the plan output to JSON, apply your policy before you actually go through and sort of run it. So, for example, here is kind of cut off at the side. So this is an example of where you make a change, and that change could result in, it could be a one-line change, and if you do it, it's going to delete your VPCs, it's going to delete your routes, and you're like, I didn't intend to do that. Like, that's not what I intended. That's quite a common problem that people have as they sort of learn and understand Terraform. Unless they're careful, it can do things that you didn't expect. It's doing exactly what it should do and what it's supposed to do, but it can sometimes be a little bit of a problem for people to spot. So this policy, for example, is, you can see there in the middle, it's assigning weights here to different classes of operations. So like a delete, that's costly. You know, we shouldn't expect you to do a delete. Obviously, you could have different flows with different policies applied for cases where you knew you were deleting. So it can be specific to what you're trying to achieve. So we've weighted everything here, and we're maybe only looking at a subset of resources. And then the policy is we're just making sure that the score, so the aggregate score of all the weightings, is less than the configured blast radius, which we set that to 30 below. And we also have another rule that you also can't touch the IAM. So you can't change your IAM config when you do this. So the blast radius, it's just so scores it's just basically another function or another sort of rule, and it's running through and it's aggregating all the resources in the object. This is a little bit more complicated. It makes sense after like you've played around with OPA a little bit, but ultimately what this is doing is it's going through every single resource in your Terraform plan. It's looking at the ones that you've included in your whitelist. It's pulling out the weights associated with them, and it's summing all the weights, and you're ending up with a score that's representative of how damaging your change could be. And then the IAM rule is just checking to see that you're not trying to change an IAM rule. So it's checking for the occurrence of IAM, and if you've more than 0 being changed, no, go away, you're not allowed to do it. So, this is what it would look like in practice. I was going to demo it, but you won't probably see it on the screen. Terraform init, Terraform plan, outputting the plan in binary, a show to convert the binary output to JSON, and then you're evaluating your policy. So the Rego, the rules that we just saw are in this Rego file here. The input is the plan from above, and what we're doing here is the data Terraform analysis auths. This is the output of running the policy, which for the auth part is going to be true or false. You're allowed to do it, you're not allowed to do it. Also in the analysis from running the policy, you're going to have a score, so you can additionally see the score. We're getting it there. And this would be something that you would just bake into your pipeline. This would just be something that would sit, and it would say, you can't do it because you've tried to change these things. Changes are only allowed to impact this volume of things. So you suddenly have more checks and balances that stuff is being sort of done right. So you kind of want compliance everywhere. Like, it's the point of having a consistent system. Kafka is another big example. So Kafka has an authorizer interface. There's an example in the project of an implementation of an authorizer plugin that runs with Kafka. And what it does is it offloads authorization to an OPA daemon. And it allows you to do authorization. It allows you to do filtering. So you can kind of, at runtime, by changing the configuration in the OPA daemon, you can sort of limit who can see what and what, suddenly you're starting to you can control very granular things that would have required development cycles. Very easy to try. So the documentation is very good. It's getting better and better and better. I think there was version 15 just got released this morning, I think. I also put together, I was going to do a live demo. I have a Katacoda scenario that shows Gatekeeper 1. So it uses Katacoda to spin up a Kubernetes cluster, sets up the secrets, creates your certs, deploys OPA, deploys a policy, and then shows you it running and failing and passing. And you can just do that in your browser. So Katacoda is a project, it's run out of London. It's very, very good. So getting involved. So subscribe to their Twitter feed. It's worth doing. The project on GitHub, so the main project is OPA. The one that's seeing a lot of attention as well at the minute is Gatekeeper, which is like the Kubernetes native solution. And they have a very active Slack group. It's very active. And that is about it. I finished on time, amazingly.
Unbelievable. Thank you, John. Are there any questions? Questions for John? You were very, very
presentation
clear.
was
It's
perfect.
unbelievable. It's unbelievable. All right, give him another big hand. Thank you very much.